Okay, so we're going to do another shell method problem here. It says find the volume of the region in quadrant 1 bound by y equals 2 minus x squared, y equals x squared, and and x equals 0, rotated about the y-axis. So let's try and graph this out. These are fairly common things we're going to put together here. So on the x and the y-axis. Let's see here. The two easier ones to work with are the y equals x squared. So that goes through 0, 0, through 1, 1, and through 2, 4. 2, 3, 4. I don't think we need that far out. And also on the opposite side, on the negative side, we get something similar. So we get, of course, our regular parabola. And then the other one, so I'll just put this here, y equals x squared. So the other one here, which is y equals 2 minus x squared, that one comes up to a y-intercept of 2, and it's flipped over the x-axis, so it's an upside-down parabola. And if you count it off or actually graph it, you'll see it goes through 1, 1, and it goes through negative 1, 1. But this thing says in quadrant 1, so that's cut off by the x equals 0. So that gives us a little floating bullet shape in quadrant 1. Okay, and it says we're going to rotate that around the y-axis. So we're going to rotate that around the y-axis. So we already kind of have the mirror image on the other side, but that wasn't the region that we put in there. So let me see here. This bottom one was y equals 2 minus x squared. So around the y-axis, we want everything to be in terms of x. So my volume will be 2 pi, and we'll have bounds in terms of x. So along the x-axis down here, the bounds will be from 0 to 1. That's the place that the region exists for us. So let's see here. So the bounds will be from 0 to 1 on the x. And then we need a radius. So coming out from the line of rotation, which was the y-axis, x equals 0, will come out an x amount. And this one's a little bit different than the previous example, okay? Because now we need a height. So in this case, we'll say that the radius is x, but the height that we're working for is different in different places. So it's always bound on top by the red line and always bound on bottom by the blue line. So the height of this thing would be from the top, which is 2 minus x squared, down to the bottom, which would be x squared. So that's the top, 2 minus x squared, minus the bottom. So we'll write this as 2 minus 2x squared. So that will be our height. So our radius and our height. Hold on here, something got weird. I want to change something. Are in terms of x. So x for the radius, the height will be 2 minus 2x squared, and that'll be dx. So take a look at that for a moment and make sure you feel good about it. So the height might not be defined by a single function, because as we move along here, we'll have big cans toward the center and small cans as we move away from there. So really thin bands as we move away from the center. But once it's set up, it's really easy. So volume is 2 pi from 0 to 1. And let's distribute here. So we'll have 2x minus 2x cubed dx. So we're going to integrate, which means reverse our power rule. Don't need a u substitution here. So 2x integrates to be x squared, and minus 2x cubed integrates to be minus 1/2 x to the 4th. And that'll be from 0 to 1. So let's plug everything in here. Let x equal 1. So we'll have 2 pi, and this will be 1 minus 1/2, so it'll be times 1/2. And then minus, we'll let x equals 0. So that'll be 2 pi times 0 minus 0. So we'll just mark all that out. So it looks like the total volume we get is just pi. Okay. Sometimes it's hard to tell if you've got a large region or a small region depending on how big it is and how things rotate. So let's stay with that for right now.